we finished the immune system flashcards, it's good to go over the quick one-page summary as well. I went over the innate and adaptive immunity. Then we have the innate immune system on the left here, and we have the adaptive immune system on the right. And we have the lymphatic system at the bottom here. So the first line of innate immunity is our skin. So here we have, if you remember, we were searching for the difference between defensins and lysozymes. And we have here that lysozymes are, so lysozymes are in tears and saliva, and however the similarity they have with defensins is that they are both antimicrobial compounds, antimicrobial enzymes. And we have the mucus. So on so mucus is on the mucous membranes. It's on the epithelial cells, I believe, and it traps pathogens in the respiratory system. So we have mucus on both our saliva. We have it on in our respiratory tract. So we have it in our not airway pathways, and the mucus is propelled upward by cilia via mucociliary escalator. So actually mucus goes against the direction of gravity, and it can come upward via the mucociliary escalator. So we can definitely take a look at its pictures. Mucociliary escalator. So this is a healthy mucociliary escalator. We can see that the mucus can come up very easily and rapidly, but an unhealthy mucociliary escalator takes longer, and it's like walking on stairs compared to escalator. That's a good reference, actually, since we have an escalator. So the respiratory zone is at the end, where the alveoli are interacting, exchanging O2 and CO2 with the blood vessels. And in apparently cystic fibrosis people, the goblet cells secreting mucus. So apparently it is the goblet cells that secrete mucus. The mucus transport is slow in primary ciliary dyskinesia, PCD. The cilia cannot move well or at all, and mucus and germs build up in the lungs because the cilia cannot propel them out. Coughing can help move it out. And so this is what happens with the mucociliary escalator. So still I'm not sure if it's a cell by itself or if mucociliary escalator is a mechanism. So we can ask it from here. Is the mucociliary escalator a cell or a mechanism by which mucus moves upwards, propels upwards. So again, we had lysozymes. We have the complement system, where it complements the immune system with helping with the antibodies, I believe. With so they can punch holes in the cell walls. The complementary system, the complement system, it can punch holes in the cell walls of bacteria, making them osmotically unstable, which leads to their lysis, and it also triggers opsonization. If you remember, opsonization is also it's where antibodies mark pathogens for destruction. So we need mnemonics or ways to keep these in mind and remember them. Now, for interferons, they interfere with the virality, so they are given off by the infected cells, and virally infected cells to be specific, and it helps to stop, to prevent the virus from replicating and dispersion and replication of the viral loads. And these were non-cellular innate defenses, so skin, mucus, lysozymes, complement system, interferons. These are non-cellular innate defenses, and they have cellular innate defenses. So the cellular ones are macrophages, MHC1 and 2, dendritic cells, natural killer cells, and granulocytes. So what happens with cellular innate defense? So this is still non-specific, right? So macrophages ingest pathogens. So what do macrophages do? They ingest pathogens. And how can that help our immune system? They present them on their MHC2. They also can secrete cytokines, and cytokines, do we have them anywhere here? We need to know what cytokines are and where are they helpful for. Now, MHC1 is present in all nucleated cells. It means that it's not present on red blood cells, for example, but it is present on lymphocytes because they are nucleated, right? They display endogenous antigen to cytotoxic CD8 plus T cells. So CD8 plus T cells are natural killer T cells. And it's endogenous antigen. MHC2, on the other hand, is present in professional antigen presenting cells. So macrophages, dendritic cells, some B cells, and certain activated epithelial cells. They display exogenous antigen to helper CD4 plus T cells. And we have dendritic cells where they are antigen presenting cells in the skin. And we have natural killer cells where they attack cells low on MHC, including virally infected cells and cancer cells. Now, granulocytes are consist of neutrophils, basophils, and eosinophils. So neutrophils are activated by bacteria. Eosinophils are activated by parasites and allergens. And basophils are activated by allergens. Neutrophils conduct phagocytosis, Eosinophils, they increase histamines. So it's mainly for allergic reactions, and basophils inhibit blood clotting. Now, the lymphatic system. So the circulatory system that consists of one way. So what we know from lymphatic system is that they contain white blood cells, and it allows the white blood cells to circulate around the body, to be everywhere, and to fight against pathogens, infected cells. So it's a circulatory system that consists of one-way vessels with intermittent lymph nodes. So there are lymph nodes, like stations, like train stations, and interestingly, the vessels are one way, and it provides for mounting immune responses. So when you have increasing immune responses, it provides for that. It connects to the cardiovascular system via the thoracic duct in the posterior chest. So behind your chest, the lymphatic system is able to connect with the cardiovascular system via the thoracic duct. It equalizes fluid distribution, transports fat and fat soluble compounds in chylomicrons. So if we are asked what are chylomicrons, they are fat soluble compounds, where they are distributed. They distribute fluids in the lymphatic system. Edema results when the lymphatic system is overwhelmed and cannot drain excess fluid from tissues. Now we also have the adaptive immune system. So we have humoral immunity and cell-mediated cytotoxic adaptive immunity. So humoral immunity, we know it because humoral refers to fluids. It's about antibodies that move in the blood, in the fluid, and it centers on antibody production by B cells. It kills antigens while they are floating around in the fluid in humor. So it kills the antigens while they are in our blood. So we have B lymphocytes, B cells. They are made and maturized in bone marrow. They are activated in spleen or lymph nodes, and they express antibodies on its cell surface. So everything we're going to talk about, we should know where they are made, where they become a mature cell, and where they are activated, and what do they express. So for example, B lymphocytes, they are made and maturized in bone marrow. They are activated in spleen or lymph nodes, and they express antibodies on their cell surface. So what are antibodies? We know they are proteins, glycoproteins, to be specific, I believe. They are produced by plasma cells, which are activated B cells. So when B cells are activated in spleen or the lymph nodes, they become plasma cells. They target an antigen. They contain 2 heavy chains and 2 light chains. They have a constant region and a variable region. The tip of the variable region is the antigen binding region. And we have also hypermutation. So it's a mutation that happens on the variable region of the antibody. It's a mutation of the antigen binding site on an antibody. If you see me not hovering with the mouse scroller, It means that I am trying to retrieve the information from my from what we studied like today, and I'm trying to just retrieve it based on whatever that comes to my mind. This is a very good way of bringing back the information and solidifying it into our long-term memory. And so again, hypermutation is a mutation of the antigen binding site. So it's basically the variable region, tip of the variable region on the antibody. It results in varying affinities of antibodies for a specific microbe. So we have 5 different isotypes, and the reason we have IgA, IgE, D, G, and M is that we have hypermutation. So it results in varying affinities of antibodies. So all these antibodies have varying affinities for specific microbes. So for example, IgM attaches to the first pathogens that we are exposed to, and IgG is mainly for phagocytosis. So we have opsonization. Opsonization is like tagging the, marking the pathogens by antibodies. So when antibodies mark the pathogens for destruction, it is opsonization. We also have agglutination. Agglutination is clumping up of the pathogens by antibodies. So pathogens clump together into insoluble complexes caused by opsonizing pathogens. So there are opsonizing pathogens that cause this. We have memory B cells. They are a subtype of B cells. They lie in wait for a second exposure to pathogen. The secondary response is more rapid and vigorous. So they wait for a second exposure to pathogen, and the secondary response is more rapid and vigorous by facilitated by B cells, memory B cells. We have cell-mediated cytotoxic immunity. They center on T cells. So the cell-mediated cytotoxic immunity, they center on T cells instead of B cells, which was the humoral immunity. They respond to cells once they have been infected by the antigen. So once these cells have been infected by the antigen, T cells respond to that. Remember that in case of the humoral immunity, they kill antigens while they are floating around in the fluid in our blood. But for T cells, for cytotoxic immunity, it takes place when our cells are already infected, so by the antigen. Now, the T lymphocytes are made in bone marrow. However, they become mature in thymus, and the coordinate immune system, and they coordinate immune system and directly kill infected cells. So they just go around our body and try to directly kill infected cells. That's why they are called cell-mediated immunity. Now we have positive and negative selection for the maturation of T cells. It's facilitated by thymosin, which occurs in thymus. I believe this is the only place that we are going to encounter thymus. So we don't need to know much more about thymus and thymosin. All we need to know is that it's for the maturation of T cells. So the positive selection is when mature only T cells that can respond to the presentation of antigen on MHC. So whenever it's affiliated with MHC, you only mature T cells that can respond to the presentation of antigen on MHC, but negative selection causes apoptosis in T cells that are self-reactive. So if they cannot detect self antigens, and they react to our self cells. Then apoptosis of T cells happens, and basically they die because they're useless, and they can even harm our body with autoimmune diseases. Now we have helper T cells. Um, which is written as TH or CD4 plus. They respond to antigen on MHC2. So when you have the MHC2 or the MHC1, we know that it's regarding cellular innate defense. But when the helper T cell is involved, then we know that it's an adaptive uh, immune response. So the helper T cell, TH or CD4 plus, responds to antigen on MHC2. The coordinate rest of the immune system, secreting lymphokines to activate immune defense. So we can explore more about lymphokines, which activate the immune defense. We have Th1 and Th2. Th1 secrete interferon gamma, and Th2 activate B cells in parasitic infections. So we did not come across this for during the flashcard revision. So this is something that we know that interferons are part of the innate system. They basically are given off by virally infected cells to interfere with viral replication and dispersion. We have cytotoxic T cells, TC, CTL, or CD8+. They are killer cells. They respond to antigen on MHC1 and kill virally infected cells. So CD4+ is with helper T cells, and CD8+ is with killer cells, cytotoxic T cells. So they respond to antigen on MHC1 and kill virally infected cells. So MHC1 and CD8+, they kill infected cells, right? But CD4+ is for secreting lymphokines to activate the immune defense, and it's for parasitic infections or interferon gamma. We can delve into that later. We have suppressor T cells. What I remember from suppressor T cells is that they help to differentiate the self versus non-self cells, and this helps in reduction of the autoimmune risk of autoimmune disorders. So the Treg it downregulates the immune response after an infection and promotes self-tolerance. So we want to tolerate ourselves, and good high self-tolerance is good because it means that we are tolerating our self cells, and they are defective suppressor T cells. Defective suppressor T cells lead to autoimmune conditions. So when these suppressor T cells are not functioning well or at all, they are defective, and that leads to autoimmune diseases. We have memory T cells that serve a similar function to memory B cells. So they remember what happened from the past, and they will kill the antigens. The autoimmune conditions, they are a self-antigen. So a self-antigen is recognized as foreign, and the immune system attacks normal cells. We have allergic reactions where non-threatening exposure incite an inflammatory response. We have immunization, which induces active immunity, activation of B cells that produce antibodies. And we have passive immunity, which is the transfer of antibodies to an individual, like breast milk. So breast milk is a good example of passive immunity, and active immunity is activation of B cells that produce antibodies. Immunization, like probably vaccines. So we can ask, are vaccines a good example of active immunity? What are some examples of passive immunity other than breast milk? Okay, I believe for now we have covered a good amount, a decent amount of the immune system as well. So we have both cardiovascular system and the immune system covered. And however, we know that immune system needs a bit of more work, but with more questions, we can get down to the nitty-gritty details, and with more practice, we are going to make sure that we are not gonna miss anything on these two topics. And here I will write down immune system. Okay, so for the next topics, after doing some practice questions on these subjects, we can go forward with the biology section, or we can change things up. So we will see. I know that the kidney and skin is also related to what we just had for the cardiovascular system. So it might be good to cover this next. But the digestive system is also should be pretty smooth, and we have the mucous cells, as you can see. So there are some similarities between the digestive system and the kidney and skin. So yes, we can definitely cover them in the next topics, so that we are having an easy time with the rest of the topics. The more topics, the faster, the better, right? So for now, ciao.